Hello, today I will continue my introductory guidance to the quantum mechanics series, and today it's lesson 7. We will talk about what is the difference between uh, classical and quantum mechanics principle uh, for in the views of quantum mechanics studies. So we have two different theories. They were introduced. The first one is the statistical and the second one is the deterministic. So statistical is described by the quantum mechanics, while the deterministics is described by the classical classical physics. So the macroscopic object and microscopic objects, it can be including any very large particle or small particles, so particles or electrons, for example. Behavior description are different for those classical and the quantum mechanics. So in this class, our target is to point out the statistical approach, which is studied by quantum mechanics, and deterministic approach, which is studied by the classical physics. So classical physics takes on deterministic's approach to studying the behavior of macroscopic object or also microscopic object. According to the deterministic theory, it's treating atoms as simple particles. So if we may know a certain quantity or values, for example, maybe the velocity, the position of that particle, as well as the forces applied on that particle, for example, maybe gravity or any kind of external forces working on that object or particle, so we can predict the future position and the pathway where this particle would go of that object. For example, if we let an object fall from a specific known height, for example, it's 250 meters, and it's defined as the initial position of that particle at the initial time equals 0, neglecting any other forces except the gravity. So we can determine the exact position of that object at any later time. So by knowing the gravity, which is we are just keeping the external applying force on that object, is the only forces applied to this object. So here I am saying object or particle because object maybe it's sometimes describing the larger thing, so it's microscopic, and particle for microscopic. So both of them, they are treating equal in classical physics, in deterministic's approach or theory. In classical physics, knowing the initial position and initial velocity, we can determine the future pathway the macroscopic or microscopic object will follow. However, quantum mechanics takes completely different approach than classical physics. So we already saw in the double slit experiment class with electrons that there is no way of knowing the pathway of an electron that it will take, nor we cannot know, and there is no possibility to know the exact electron position will end up with extreme certainty. So in fact, Heisenberg's uncertainty principle tells us that it is impossible to know precisely the exact velocity and position of an electron at any moment of time. But we can still describe the future position and velocity of such particle using a probability. So it's not 100% certainty, not exact, not deterministic. So it's different interpretation with that described by classical physics for micro or macroscopic particles. So instead, maybe this is just a kind of summary, quantum mechanics uses a statistical approach. Even though we cannot predict where any of these electrons ends up, we can describe the future position of electron particle using the probability principle. So this kind of different interpretation or contradicts in different interpretation between classical and MD can be called as or described by or called as Copenhagen interpretation. So this interpretation of nature, it is, I mean, this interpretation, Copenhagen interpretation, states that there is an inherent uncertainty in being able to predict the pathways and the quantities that describe the motion of an object. This uncertainty comes from the fact that ordinary objects don't simply behave as particles, but also can behave as waves. So this is the different nature description for the particle. It's not solid particle, it's sometimes behave as wave. So according to quantum mechanics, since electrons are not simple particle, they cannot follow any simple pathway that is predicted by the deterministic approach. So finally, classical assumes all microscopic macroscopics are exact particles, that are means if any quantities or certain quantities are maybe known, then other information such as velocity pathway will be known as well in another side. For quantum mechanics, it is a statistical approach, probability description approach. So for example, if the particle cannot be determined where it will goes finally in next path, but we can probability detect with some uncertainty where it will goes, because due, and we cannot certainly assure because it's due to the particle wave nature that it sometimes behaves. Thank you.